data collection we did really helped us with our plans to create a coherent, streamlined STEM pathway for our students through the redesign of courses and also with plans to add new courses. However, there was a bit of confusion between the three disciplines within our program. It was simple to see how each was related within our STEM program, like how the robotics experiences utilizes technology and computer science within their projects. However, there was confusion on what a technology course entailed and how it differentiated itself from the robotics courses. Ultimately, through the process of defining technology, the discipline is now called Technology and Design. Adding the term design emphasizes on the creative problem-solving element of the discipline, as well as focuses on the human element of innovation. Students develop a broad skill set in design thinking, systems thinking, and problem-solving to create solutions using technologies, considering the user experience and ensuring their creations resonate with different audiences. But this distinction then required us to identify standards that specifically align with this discipline, which led to the introduction to the STEL standards. This helps differentiate technology and design with robotics, since robotics specializes in building and deploying robots, preparing students for careers in specific industries like manufacturing, healthcare, and logistics. With this distinction, it made it easier for us to redesign the high school technology and design and robotics courses to help create coherent, streamlined STEM pathways for students. Martin Williams, Paul Booth, and James Harvey all met to see how they could redesign their courses. As a result, 2 separate courses from each discipline were redesigned to be more aligned and to create a pathway. In addition, Nabia Khan started the process of creating an artificial intelligence course for the following year. And with enough enrollment, we could possibly start the process of creating an AI 2 course. With the help of Janelle Gaskell from the Office of Learning, the process was divided into 7 sections that helped Nabia have a clarity of the deliverables that needed to be executed. Course overview, standards and competencies, scope and sequence, assessment and evaluation, types of learning engagements, understanding by design plans for each unit, and finally budget and resources. So here's the current STEM pathway. Based on what students are interested in, they have a pathway of following the technology and design pathway, a computer science one, or robotics engineering. As you can see, at the start of their STEM journey, they experienced the STEM integration model, meaning that their technology and design, computer science, and robotics lessons are part of an interdisciplinary unit that involves core disciplines like social studies and science, therefore guaranteeing each student gets STEM experiences in each quarter of the year. Once students leave elementary school, they have the option to take electives and continue their pathways in technology and design, computer science, and robotics. Led by Cal Cho and Melissa Traynor, middle school coding has been through a redesign itself, aligning their courses with elementary and high school. In the years to come, we are planning to also implement the STEM integration model in the middle school, integrating STEM into their current interdisciplinary units. High school students who are interested in technology and design can continue their learning through the Engineering Design 1 and 2 course. For robotics, they can continue with Robotics 1 course and the Robotics 2 course. In computer science, students can continue their pathways with Computer Science 1 to a pathway in Artificial Intelligence or a pathway towards AP courses. With all this work, it was now time to map out all the changes we made to our scope and sequence. Because the initial scope and sequence was built on a spreadsheet, it became cumbersome to modify and didn't offer a clear view of the entire STEM learning journey. To address this, I decided to explore Coda for our second draft scope and sequence. With Coda, our scope and sequence is presented through easy-to-understand cards, where each card represents a unit or course, giving you a wealth of information at a glance. You can also filter the cards based on division or disciplines. This platform's flexibility also allowed for easier modifications and, more importantly, provided a holistic view of students' STEM experience. However, since we also needed a way to store and access our STEM content standards, as well as connect them to our scope and sequence, we decided that Coda would be the tool for this as well. Divisions first took a look at our standards and used the R.E.A.L criteria to prioritize standards, identifying power standards. R.E.A.L stands for readiness, ensuring the standards build upon essential knowledge and skills students need for success in the next unit, course, or grade level. Endurance, focusing on knowledge and skills that are valuable beyond a single test or unit of study, fostering long-term learning. Assessed, indicating the standard is formally addressed through tests or other measures, allowing for tracking student progress. Leverage, highlighting standards that can be applied and built upon in other subjects, promoting interdisciplinary learning. I uploaded all the standards into Coda, then identified which of the standards were power standards for each discipline. STEM teachers can now find power standards and filter them by bands and concepts.